Okay. Can we start or should we wait for some time? The recording is already started, okay? So till then, okay, participations are increasing anyway. So till now, I just want to go for revision only. Okay, so till last class, uh, under this railway engineering, we have discussed about uh, a basic background of railway or railway engineering, a history of Indian Railway, and in the last class, basically, we are started a tactical uh, understanding of railway. Okay. Okay. Someone asking me something. Let me write. Okay. Wait. Okay. So in the last class, we discussed about a particular component, very important component of railway engineering, that is rail. Okay. So you all know these things. Rail is a I don't remember. It's a high wheel steel member, uh, and it's used to lay on a particular track over which a train moves, okay, in a particular restricted path. And we already discussed about different types of rail, okay. So in today class, we're going to discuss about track gauge. Okay, it's a very important topic also in terms of railway engineering. Fine. So let's start. So first of all, let me share my screen. Okay. Can you see the screen? Can you see? Is it visible?
Yes, sir.
Okay. So I'm showing the same profile, cross-sectional profile of railway track. Here you can see it's a cross-sectional view of a railway. Here you can see the rail. You can see the cross-section of the rail. Okay. Then the sleeper. Here you can see in the orange color. Sleeper. Below sleeper there is a ballast. It's made of aggregate, coarse aggregate. Then sub-ballast. It's also made of a coarse aggregate. Then subgrade soil, and below that subsoil. Okay. And the load is the moving load of that train is transferred to the rail through the axle and the wheel as a point load, and the point load from the rail it goes to the sleeper as a line load, and from the sleeper to the ballast and so on below It's travel as a area load. Okay. So these things already discussed in the last class. So in this class we are going to discuss about gauge. Okay. Here you can see the drawing of the gauge. From there you can easily understand what is actually the gauge mean. Here you can see the from the diagram also itself, it is showing the distance between the inner face of the rail is defined as a gauge. Okay. So the clear minimum horizontal distance between the inner faces of the two rails forming a track is known as gauge. Okay. So the distance between the inner face of two rail is known as gauge. That's why it's also known as track gauge. Okay. So Indian Railway, yeah, it's also follow this standard. We have in India also we have some standard gauge. Okay, that means the track dimension track width we have a standard gauge. Okay. So here you can see the line diagram. On the sleeper, the rail is attached by the fastener. You can see. I think we already discussed about the fastener also. Fastener is used to uh, fix the rail with the sleeper. Okay, and the gap between the inner gap between the two rail is known as gauge. Okay, so if I tell you about the history of gauge, so in different country, various gauge have been adopted by different railways in the world due to the historic and other consideration. Okay, there are many based on the origin of the area, based on the origin of the country, specific country. Different gauge or track gauge is was used in different countries. Fine. So if I say in British or in initially in British Railway had adopted a gauge of 1525 millimeter. It's about 5 feet. That means that British railway track are laid with having the rails are placed 1525 millimeter. You can say 5 feet apart. Okay, uh, and gradually it was then reduced. The gauge then become 1435 millimeter. Okay, to get the to make more stable movement of the train. Okay. Yeah, so the 1435 millimeter gauge become the standard and most European railways. So you can say this 1435 become universal at that time, and we are talking about the history of world. So if I say in India, so even in India also we have different gauge. If you see the history, it started from the British India, or you can say East India Company. So the East India Company intended to adopt the standard gauge of 1435 millimeter in India also, since it was proposed by from British Railway only. So same gauge was used before in India before independence. That is 1435 millimeter gauge was used. Okay, but it was challenged by W. Sims, a consulting engineer to the government of India, who recommended the use of wider gauge of 1676 millimeter. 1676 millimeter. Okay. So finally, the court of directors of East India Company decided to adopt Sim's recommendation, and this 5 feet 16 finally become the Indian standard gauge. That is 1676 millimeter. Fine. After that, after even here in 18th century, in 1871, the government of India wanted to construct a cheaper railway for the development of the country, and finally come up with a new gauge that is 100 millimeter. Um, it's the particular gauge is also known as meter gauge. Okay, so there are specific name for different gauge length. Okay, if the gauge length is suppose 1000 millimeter or 1 meter, that particular track is known as this meter gauge. Okay, it was introduced in 1871. Okay, we're going to discuss in which area or in which condition the different gauges are used. We're going to discuss. Okay, so don't worry about that. Next, after that, with due course of time, two different gauges are introduced, and they are known as uh, I think it is given here. Okay, two more gauges are introduced having this millimeter, that is 762 and 610. Okay, for thinly populated area, mountainous railway. Fine, and they are also known as narrow gauge. Okay, so if you see in this tabular format, if you see closely in tabular format, various gauge in India on Indian railways as up to the date of 2011. Okay, up to this, so this data reflect of Indian railway track length for up to 2011. Okay, so in India we have three gauge: broad gauge, okay, then meter gauge and narrow gauge. Okay, so BG, MG, NG. Fine. So even in somewhere in the railway track also it may be written, okay, whether the particular railway track is broad gauge, meter gauge, or narrow gauge. You can also check. Fine. So you know the broad gauge or meter gauge or narrow gauge have a specific width. Okay, the width means the distance between the inner face of the rail. So for broad gauge, it is 1676. For meter gauge, it is 1000 millimeter. We're talking about all the dimensions are in millimeter. Okay. And for narrow gauge, we have two type of width. That is, one is your 762 and 610 millimeter. So up to 2011, total track length in kilometer for broad gauge was 55,188. For meter gauge, it is 6,809, and for narrow gauge, it is 2,463. So from this data also you can see the maximum track length or tracks are, or you can say in India, maximum tracks are made of broad gauge only. Okay. Now we are going to discuss about broad gauge, meter gauge, and narrow gauge in specifically. Okay, that means what is the meaning of broad gauge? Okay, and the background about that particular gauge and where in which condition that particular gauge is used. So here you can see the basic definition of broad gauge is what? So when the clear horizontal distance between the inner face of two parallel rails forming a track is 1676 millimeter, the gauge is called broad gauge. Okay. Yeah, wait, stop over. Okay. When the clear distance between the inner faces of two parallel next second. Okay. So when the clear horizontal distance between the inner faces of two parallel rails forming a track is 1676. This is very important to remember. Okay, you have to remember this. The the clear distance between two rail inner face of the rail in case of broad gauge is 1676 millimeter. Okay, and the gauge is known as broad gauge. In short, BG. This gauge is also known as standard gauge of India. Okay, and it is the broadest gauge of the world. That means it is the maximum width that was applied till now. Okay, in any country, that is 1676 millimeter. It is also known as standard gauge of India. So if somebody asks you what is the standard gauge of India, that is broad gauge. Okay, or if someone asks you what is the clearest distance in standard gauge of India, it will be 1676 millimeter. Okay. So if I say other country that use broad gauge are like Pakistan, Bangladesh, Sri Lanka, Argentina, Brazil, all these country also followed or use this gauge, that is broad gauge, having the dimension of 1676 clear distance between inner face of two parallel ray. Okay. Now let's discuss about suitability. That means in which area or in which condition this broad gauge is suitable or can be applied. So, broad gauge is suitable under the following condition, and the conditions are when sufficient funds are available for the railway project, and when the prospects of revenue are very high, very bright, or we can say very high. Okay, let's wait. Someone is waiting. Okay, yeah. कहाँ था हम लोग? हाँ. This gauge is very this gauge is therefore used for tracks in plain areas which are densely populated, that is, for routes of maximum traffic intensities and at places which are centers of industry and commerce. Can you get this point? So the larger the gauge, the larger the gauge, you can see if you see that drawing here, the larger the gauge length, the cost of a railway track will be high. Okay, you need more ballast, you need a larger sleeper, okay, and you need maybe a height width rail, okay. So ultimately, the overall cost of the railway track will may get high, not too much, but to some extent it may increase the cost of the construction or cost of the maintenance, whatever. Okay, so when you're going to adopt broad gauge, you have to ensure that whether there is a bright feature of development or not. Okay, whether if the area is so populated, that means from population area, that means the more people going to use that train. Okay, and if the peoples are going to use the train, it will indirectly, or you can say that directly, it will increase the revenue of the government. Fine. So in a populated area, or you can say if the industry oriented area, or if the particular area is so having maximum traffic in that place or in that area, we a broad gauge can be used. Okay, so that means by expensive that much of amount also, it's giving you back as a revenue. Okay, so revenue is very important term here when you are going to lay your gauge. Okay, fine. Next, if we discuss about meter gauge, so like the same definition, when the clear distance, clear horizontal distance between the inner face of two parallel rail forming a track is 1000 millimeter, the gauge is known as meter gauge. In short, MG. And the other country uses the name of the countries are like France, Switzerland, Argentina, like etc. Okay. So here you can see more about 50% of Indian railway are made of your broad gauge, and about 40% of Indian railway are made of meter gauge. Okay. Now, what is the suitability? So meter gauge is suitable under the following condition. Here you can see the difference between broad gauge and meter gauge now. When the fund available for the railway projects are inadequate, suppose the fund is not much, we don't have that much of fund. So, or you can say if you don't have much fund for meter gauge, sorry, we don't. If you don't have fund for broad gauge, then we can go for meter gauge. Okay, since meter gauge have a lesser width, 1000. Okay. Next point of suitability, that is when the prospect of revenue are not very bright. This gauge is therefore used for tracks in underdeveloped area or in interior area where traffic intensity is small and prospect for future developments are not very bright. That means in some small areas, rural areas, okay, and where the population is not that high, okay, and revenue generation is not that uh, much expectation. In that case also we can go for meter gauge. Okay. Now if we discuss about narrow gauge, so when the clear distance between when the clear horizontal distance between the inner face of two parallel lines to two parallel rails forming a track is either 762 millimeter or 610 millimeter, the gauge is known as narrow gauge. In short, NG. And the other country using narrow gauge are like Britain, South Africa, etc. And 10% of Indian railway track are laid to this gauge. Okay. So, suitability of narrow gauge. The narrow gauge is suitable under the following condition. And conditions are when the construction of a track with wider gauge is prohibited due to some provision of sharp curve, steep gradient, and narrow bridge, a tunnel, etc. That means it's depending on the natural condition also. We can, if there is a restriction or if we cannot go for meter gauge or broad gauge due to the natural restriction, like there is a very steep gradient or there is a too much curve, okay, or through a bridge, or if you are going to lay a rail through tunnel, then we can go for narrow gauge, a smaller width railway track. Okay. Next, when the prospect of revenue are not very high, the gauge is therefore used in hilly and very thinly populated area. Okay. And a feeder gauge is commonly used for feeding raw material to big government manufacturing concern as well as to private factories such as steel plant, oil refineries, sugar factories, etc. etc. So even in the larger or bigger industry, there are some internal rail travel within the within the industry campus for uh, for a movement of goods or heavy machinery. Okay, so for that also they used narrow gauge. Okay. So this is all about your different types of gauge and their uses. Okay. So if I give you a map of Indian Railway, let me give you. Let's wait. I'll show you one map. Can you see? So this is an Indian Railway map. Okay. Now you can see here also in the legends. I yeah. So you can see. Let me check. This is a map, Indian map showing railway track laid over the India, a whole India. Okay, so you can see they are different color combinations are there. Okay, so this different color represents different gods. Okay, so even in the legend also you can see we are concerned about this only. See, broad gods, two different type of broad gods are there. Okay, based on the importance. So importance broad gods, but they are broad gods only. So standard gauge, that means the broad gauge showing by this red line and this dark red and this orange line, the meter gauge, narrow gauge, okay. And where some broad gauge and meter gauge are in parallel, then it's showing like this, okay, like that. So different uh, track lines are showing here over in our Indian map, where you can see. So you can see even in the Indian map, this dark red color is widely spread over Indian map. You can see. So this red color represents your broad gauge. So you can see standard gauge. It's connected state to state also. Okay. You closely you can look. Fine. Even in if you see in Assam also or Northeast India, you can see different gauge are there. There you can see the main line. The broad gauge line is connected to different state, West Bengal. This dark red line. Okay, other lines also available here. Since we have a hilly area, so we are not using too much broad gauge here. You can see even in northeast India, there is not too much of that one. Your red line, dark red line, because this we are in a hilly area, so it is not feasible for laying broad gauge. So here you can use meter gauge, or yeah, you have used meter gauge here only. Okay, all are meter gauge now. Fine. It is clear now. Is it clear till now?
Yes, sir.
ठीक है. Very good. So is there anything else? Let me check. Okay. Yeah. So there are last point of discussion here. Choice of gauge. Okay. So basically, we already discussed about feasibility or suitability of different gauge. But anyway, theoretically, uh, some points are there based on which we can also go for considering different gauge. Okay. So the choice of gauge is very limited. As such, country has a fixed gauge, and all new railway lines are constructed to adhere to the standard gauge. However, the following factors theoretically influence the choice of the gauge. Okay, so you have to go through this part also. So, what are the point influencing the choice of gauge? Like cost consideration. Cost is very important point. Next, your traffic consideration is a very important point also. Then, physical features of the country, uniformity of the gauge is also one of the important factor. Fine. So let's read out once. So cost consideration. There is only a marginal increase in the cost of the track if a wider gauge is adopted. In this connection, the following points are important. Okay. So I already told you that uh, if you increase the uh, width of that gauge, okay, then the cost will increase, but not that too much, but too slightly the cost will increase. Okay, but at what point the cost is mainly effective. Okay, we are going to discuss now. So the following points are important. Like there is a proportional increase in the cost of acquisition of land, artwork, rail, sleepers, ballast, and other track items when constructing a wider gauge. That means if you go for wider track, that means we need more area. Okay, that means we need to acquire land. Okay, so it also included cost of the land, extra land that you are going to acquire, then artwork, then size of the sleeper, that amount of ballast requirement, all will going to increase. Okay, we're going to discuss about ballast in coming classes, so don't worry. Then the cost of the building bridges, culvert, running actually this tunnels increases only marginally due to the wider gauge. The cost of constructing a station, buildings, platforms, staff quarters, level crossing signals, etc., all associated with the railway network is more or less the same all for all the gauges. Okay? The cost of the rolling stock is independent of the gauge of the track, working the same volume of traffic. We're going to discuss about that. Okay. In coming classes. Next point of consideration is traffic consideration. Okay, you just go through these notes. It is very simple to understand. Okay, these things I'll share these notes even in the student portal or even in the WhatsApp also. Okay, you just go through the read it out. Okay, so till then I just want to show you something. Let's see. Yeah, uh this thing we're going to discuss in coming classes. Okay, so for now, just you can see here, if you see the wheel, this is the axle and this is the train wheel. Okay, and I already told you the train wheel is having a shape of a conical shape. Okay, so this is kind of a physical appearance of the physical concept of railway wheel. Okay, and you can see the inner face of the rail is having a larger diameter compared to the outer face. You can see the inner face. This is this part is wider. You can see the inner face is wider. Okay, we're going to discuss in coming classes. I'm showing you this one. Here you can see a close view of the rail. If you see closely, you can see the inner diameter is larger. Okay, here you can see inner face is larger. So actually, the the wheel actually attached to the rail from inside outward. Okay, so inner diameter of the wheel is larger than the outer ring. Okay, fine. This is your thread. This part is known as thread. Okay, I'll show you one diagram. Let's see. It is there. Yeah,
Sir, your voice is creaking.
it's breaking. Maybe it's maybe a network issue. Okay, can you see this diagram? This line diagram is showing a simple uh, wheel and axle combination of train. This is an axle. This is your wheel. Okay, and as I already told you, the inner face is larger in diameter compared to their outer face, and this is your inclination, and it is also known as coning of wheel thread. Okay, this is thread part. This is the thread part, and thread part is directly placed over the rail. This is the rail. Okay, and center of gravity of this wheel coming to directly on the rail. Okay, and this is this angle which make the cone. It's called coning of wheel. So even in the coming classes, we are also going to discuss about the coning of wheel, why wheels, railway wheels are made of this kind of thing. Okay, this is this part is also known as flank. Okay, so like this, let me check anything is there. Yeah, okay. Yeah. So about this, we're also going to discuss about that. Till now, uh, till now, we're going to close this class. Okay. So in next class, we're going to discuss about ballast. Then we'll discuss about coning of wheel, how wheels actually move through a railway track. We're going to discuss about that. Okay, the basic physics of behind the basic physics behind this moving of the rail, moving of train through over the rail. We're going to discuss in coming classes. Okay. Okay. So this is all about today class. I'm going to now close my sharing. Any doubt till now? Is there no doubt? Then I'll just close my recording here. Okay. Then I'll take the attendance. Wait. I'm stopping my recording.